You ate cooked food today. Maybe it was bread toasted in a pan, rice softened in boiling water, an egg changed from clear liquid into something your teeth could cut without effort. You probably thought about taste. Your body was thinking about energy. Because cooking does something so ordinary that it is easy to miss. It takes food that is difficult, fibrous, chewy, or dangerous, and begins digesting it before it ever reaches your mouth. That simple transformation may have helped change the human face, the human gut, the human day, and perhaps even the human brain. So what exactly happened when your ancestors stopped eating everything raw, and how much of your body still depends on that ancient fire? Start with chewing. A chimpanzee can spend close to half its waking day chewing. Tough leaves, fibrous fruit, raw plant tissue. Food must be crushed again and again because the body cannot easily reach the energy locked inside it. You do not live like that. You can finish breakfast in 10 minutes, swallow lunch while answering a message, and eat dinner without exhausting the muscles around your jaw. That difference is not just convenience. It is anatomy. Humans have relatively small teeth, weak chewing muscles, and flatter faces compared with many other primates. Your mouth is not built like a machine for processing hours of raw vegetation. Part of the explanation may have begun before cooking. In experiments led by Catherine Zink and Daniel Lieberman, researchers tested how meat eating and simple food processing affected chewing. Slicing meat and pounding plant foods dramatically reduced the number and force of chews required. Their results suggested that stone tools and a higher quality diet could already have started reducing the burden on the jaws of early humans. That matters because the story is not as simple as fire appeared and the human face instantly shrank. Cutting came first. Pounding helped. Meat helped. Cooking may have pushed the transformation much further. Heat breaks down food physically and chemically. It softens tough fibers. It changes proteins. It makes many starches easier for digestive enzymes to reach. It reduces the work your teeth and gut must do after swallowing. A cooking fire is almost like an external stomach. It performs part of digestion outside the body. That is the strange insight hiding inside every kitchen. Before you take the first bite, some of the biological work has already been done for you. Researchers Rachel Carmody and Richard Wrangham tested this energy difference using animal studies and found that cooked foods could provide more usable energy than the same foods eaten raw. The calories listed on a label may look identical, but the body does not always extract them equally. Food is not just fuel sitting in a container, it is a locked room. Processing, grinding, and heat change how easily your body can open the door. Now place yourself near a fire deep in the past. The light is small. There are no pots, metal knives, or ceramic bowls. A few roots lie in hot ash. Meat rests close enough to the flame for the surface to darken. Smoke catches in your throat. Fat drips, hisses, and briefly brightens the fire. Someone reaches too soon and pulls a hand back. Someone else waits. The smell travels farther than the light. When the food is finally shared, it is softer than it was before. It takes less time to chew. It may be safer. And more of its energy may become available to the people eating it. One meal does not change a species. But repeat that advantage across generations, and the pressure on the body begins to shift. A body that depends less on giant chewing muscles can build the face differently. A body receiving more energy from each mouthful can spend less time feeding. A digestive system receiving softer, higher quality food may not need to be as large or as metabolically demanding as one handling a constant flow of raw, fibrous material. This connects to an influential idea proposed by Leslie Aiello and Peter Wheeler called the expensive tissue hypothesis. The phrase sounds technical, but the basic problem is simple. The brain is costly. Even at rest, your brain consumes a remarkable share of your body's energy. Evolution cannot enlarge such an expensive organ without paying the bill somewhere. Aiello and Wheeler proposed that a higher quality diet allowed the human digestive system to become less costly, helping free energy for a larger brain. The idea remains debated. Later research has questioned whether brain growth can be explained by a simple trade between gut tissue and brain tissue. But the energy problem is real. Large brains require dependable calories. Cooking is one possible part of how your ancestors made those calories easier to obtain. Richard Wrangham has argued for an especially strong version of this idea, that habitual cooking was central to the emergence of Homo erectus roughly 1.8 million years ago. It is a powerful argument. It is not settled fact. The archaeological record does not give a clean date for the first cooked meal. Fire leaves fragile traces. Ash blows away. Open camps disappear. Burned material can also come from natural fires. At Wonderwork Cave in South Africa, researchers found ash and burned material deep inside the cave dating to around 1 million years ago, strong evidence that early humans were using fire in a controlled setting. At Gesher Beno Yaakov in what is now Israel, clusters of burned seeds, wood, and stone from roughly 790,000 years ago suggest repeated control of fire. But controlled fire does not automatically prove daily cooking. A fire can provide warmth, light, protection, or a place to gather. The transition from using fire occasionally to depending on cooked food may have happened slowly, unevenly, and at different times in different populations. Still, once cooking became habitual, it created a new kind of dependency. A human body adapted to soft, energy-rich food becomes less capable of living entirely on tough, raw foods. That is the twist. Cooking did not simply make humans stronger and more independent. Cooking may have made humans biologically dependent on technology. The fire was outside the body, but the body began evolving as if the fire would always be there. That makes cooking different from many later inventions. You can remove a phone, a car, or an electric light, and the human body remains physically recognizable. Remove food processing completely, and your small mouth, reduced teeth, limited chewing power, and high energy needs become a serious problem. The technology is no longer just something you use. It has become part of the environment your biology expects. Cooking also changed time. If food took less time to chew, hours of the day became available for something else. Tool making, travel, childcare, conversation, planning, rest. The change may have been as important as the extra calories. A species that spends less of the day grinding food between its teeth has more time to watch other faces, share information, repair tools, and remain awake together after sunset. Firelight may have extended the social day. Anthropologist Polly Wiesner studied evening conversations among Gwahawansi communities and found that talk around the fire often shifted away from practical daytime concerns toward stories, social bonds, distant people, and shared traditions. That does not prove the first cooking fires created human culture. But it shows what fire can do to human attention. During daylight, people solve immediate problems. Around a fire, the circle of thought can grow larger than the camp. Cooking also made food worth waiting for. Raw food can often be eaten where it is found. Cooked food must be brought to a place, prepared, watched, and shared or defended. That creates coordination. Who gathers fuel? Who keeps the fire alive? Who receives the first portion? Who is expected to share? Who is allowed to sit close? The first cooking places may also have become places of obligation, generosity, conflict, and trust. Again, the exact social consequences are difficult to reconstruct. Claims that cooking directly created marriage, fixed gender roles, or a particular family structure go beyond what the evidence can securely prove. But it is reasonable to say that cooking made food more social. A flame turns eating into an event with a location and a schedule. You still live inside that pattern. A microwave dinner eaten alone is technologically distant from meat beside an ancient fire, but your day is still organized around processed food. You expect meals to be soft enough to chew quickly. You expect starch to be transformed by heat. You expect meat to be safer after cooking. You expect someone, somewhere, to have spent energy preparing what you eat. And because cooked food releases energy so efficiently, the same ancient advantage can become a modern problem. Food can now be milled, refined, softened, sweetened, and processed far beyond anything a prehistoric fire could achieve. The easier energy becomes to absorb, the less work your body must do to obtain it. The technology that once helped your ancestors meet a difficult energy budget can now deliver more energy than your daily life requires. That does not make cooking a mistake. It means the original bargain has changed. Your ancestors used heat to unlock calories from a hard world. Modern food systems can remove nearly every lock. The result is a body built to value energy, living in an environment where energy arrives pre-chewed, pre-ground, and almost effortless. Still, the deepest legacy of cooking is not a single tooth, organ, or behavior. It is the fact that human evolution stopped happening only inside the body. Your ancestors changed the environment with fire. Then, the changed environment began changing them. Culture shaped biology. Biology made culture more necessary. And the two began moving together. You ate cooked food today. It may have looked like an ordinary meal. Your body was shaped by fire, and it still expects the world to cook.